Welcome to ACE Online and ACE Preparation League, my dear friends. As a part of SSC CGL preparation, today we are discussing LCM and HCF related topic. Okay. So guys, in this topic, what we are going to focus is first we'll start with the basic questions. Once basics are completed, we're going to discuss two properties related to LCM and HCF and related questions. Then finally, LCM and HCF applications. Okay, see, initially they'll mention the question, find LCM, find HCF like that. But there are questions where they don't mention LCM or HCF. We should understand in that question or in that situation, we have to apply LCM and we have to apply HCF. We should understand that. That's all regarding that application part. Let me start with the basics, my dear friends. LCM, least common multiple. Okay, so least common multiple. So in this LCM, my dear friends, let's start with the basic example. Okay, I want to find LCM for 6, 10 and 30. I want to find LCM for 6, 10 and 30. Okay, so the answer is 30. Okay, you people may know, but how you got 30 is, see, the basic meaning, least common multiple. First take 6 multiples, 6, 10 and 30, right? So first consider 6 multiples, my dear friends. 6 multiples are nothing but 6, 12, 18, 24, 30, 36 and so on, right? So these are the 6 multiples. The next number is 10. 10 multiples. Sir, why you are finding multiples? The name, what is the name? Least common multiple. Multiples we have to write for the given number. 10 multiples are 10, 20, 30, 40, 50, 60, so on. Then 30 multiples, next one is 30 multiples, my dear friends. Yeah, 30 multiples are 30, 60, 90, 120 and so on. Now here, if you just find out, my dear friends, the common, least common value, the least common multiple for all this is here 30, 30 and 30. Next, if you proceed, we'll get 60 also. Okay, common multiple 30, 60, like that we'll get 90, all those things will come going forward. But we want least common, least value, common multiples of these three. They given certain numbers. Okay, for that multiples we have to find what is the common multiples. 30, 60, 90 are the common multiples. The least one we have to note down, my dear friends. The least common multiple in all this is nothing but 30. This is the basic way, why then, what is the name, what is the justification for that? Least common multiple, my dear friends, right? Now see this, there are many methods to solve. Even suppose for the previous question, okay, we taken like multiples, all those things. See, here what you can do, the other method to do this question is, take the highest number, my dear friends. Okay, we'll take the new value, okay, instead of that which is already done. Let's go with the new value, my dear friends. LCM for 10, 12 and 15 you want to find. For example, LCM for 10, 12 and 15 we have to find. Okay, this is second method. First one elaborated method. Now this is the second method. How to calculate LCM is, take the highest number, my dear friends. Among 10, 12 and 15, the highest number is 15. Write 15 multiples. Only 15 multiples you consider. 15 multiples are nothing but 15, 30, 45, 60, so on, right? 60, 75 like that. Now see here, 15 is not divided by 10. This should be multiple of 10 also. 15 is not multiple of 10. 15 is not your answer. 30 is multiple of 10, but it is not multiple of 12. We need multiple of 10, 12 and 15, right? For all these values. Okay, 15 is not multiple of 10. 30 is multiple of 10, but not multiple of 12. No, not correct. 45 is not multiple of 10. Okay, eliminate. 60 is multiple of 10. 10 6 times, 12 5 times, 15 4 times. So 60 is multiple of all. So that's what 60 is the LCM for this. 10, 12 and 15, 60 is the LCM, my dear friends. There are many methods. For few questions this method may be helpful. For few questions other method may be helpful. You should understand all the methods, my dear friends. Depends on situation. We can apply method 1 or method 2 or method 3 also. Right. And here how to understand this is, see, the other way, LCM of 10, 12 and 15 is 60, right? What I can mention, 60 is the smallest number or least number. 60 is the smallest number or least number which is divisible by, 60 is smallest number or least number which is divisible by 10, 12 and 15. See, multiples divisible by, okay, is almost similar here. Yeah, 60 is the least number which is divisible by 10, which is divisible by 12, which is divisible by 15. See here, guys, if they give the options for the given number, okay, they give certain numbers and they'll give the option. What I can do, instead of doing LCM for big numbers, if it is a question related to big numbers, this 12 is divided by 3. My answer also must be divided by 3. 12 is divided by 3, my answer should be divided by 3. 10 is divided by 5, my answer must be divided by 5. We can verify like that also. Instead of doing like this, okay, we can also verify the option. Yes, this number is divided by 3, this number also should be divided by 3. As this is divided by 4, this number should be divided by 4. This is the smallest number which is divisible by 10, 12 and 15 and its factors, which is divisible by 10, 12 and 15 and its factors. Not only 10, 12 and 15 and its factors also I can mention. 10, 12, 15 factors as well. Okay, fine my dear friends. Now see the other method to calculate LCM. Suppose my dear friends, we want to calculate LCM for 20 and 42 for example. We want to calculate LCM for 20 and 42. We can write given number, first write it like a prime number power my dear friends. This is the other method to calculate LCM. Okay, write the given number as prime number power. We discussed in number systems while calculating number of factors, we're writing given number as prime number power. The same thing here, first you write given number as prime number power my dear friends. 20, we can write this as 4 into 5, 4 is 2 square, 2 square into 5 power 1. Okay, then 42, we can write this as 2 into 3 into 7. All are prime numbers. This is 6 into 7, 6 as 2 into 3. Now all are prime numbers, right? Now what we should do, LCM means, note down all prime numbers available here. What are the prime numbers involved here? Note down all the prime numbers. So prime numbers involved here is 2, 3, 5 and 7. Note down all that here my dear friends. Yes, 2, 3, 5, 7, all prime numbers, note down there. Now, highest prime number of, highest power of each one. For 2, what is the highest power? 2 power 1, 2 square, both are there. For 2, highest power is 2 here. So I have to take 2 power 2. For 3, highest power is 1. For 5 also, highest power here is 1. Okay. But for 2, highest power is 2. It's not like how many times 2 came. No. If it is 2 power 3 also, I should take 2 power 3. Okay. It depends on what is the highest power of 2 among this prime number power. What is the highest power of 3 among this prime numbers power? Now, we have to multiply this one, my dear friends. 4 into 5, 20. 3 into 7, 21. We'll get 420. There is other method also, I agree. But first, okay, we are just trying to introduce you what's the different methods, how to understand that. Okay, how to do that. See, first write given number as a prime number power. Okay, what are the prime numbers involved? List out all here. And highest powers of each prime number available we have to mention. Got it? So for 3, highest power is 1 only. For 5, highest power is 1 only. For 7, highest power is 1 only. We'll note down like this. So these are the methods, my dear friends, to calculate LCM. There are still more methods, but this is sufficient for us. Writing given number as prime number power and doing like this, or okay, highest number multiple, or cross verifying the options if option C is given. If you identify you have to apply LCM there, you can cross verify. Taking yes, this number is divided by 3, option also should divide by 3. Like that verification, is fine enough, okay, or highest number multiple. This method is sufficient to do LCM for the questions, my dear friends, right? Let me go for HCF now. Highest common factor or GCD, greatest common divisor. LCM, basic example how to do we discussed. Now HCF, highest common factor, or we can also call GCD, greatest common divisor. Greatest common divisor. Highest common factor, or else we can also put this as greatest common divisor. Now, we'll see, my dear friends, here the name itself clearly indicating that we need factors here. Okay, common factors. First to find the factors for the given scenario, and we have to find common factors for that, and among that highest common factor. Now let's see one basic example. We'll go ahead with, like, I have to calculate HCF for 60, 84 and 108, my dear friends. 60, 84 and 108. We need to find HCF for this. By this time, many of you people know what's the HCF for this also. Fine, but see this, my dear friends, what's the analysis, how to do? Basically, see, for 60, what is the factors we have to list out? What are the 60 factors? What is the basic method is, we need to find factors for all this. Previous one, multiples for every number given. Now factors for every number they given. So for 60, factors are 60 is divided by 1, 60 is divided by 2, 60 is divided by 3, 4, 5. Okay, it's divided by 6. Right, okay, we can do it's divided by 10, 12, 15. See, you are just listing out all the factors here, my dear friends. 20, 30 and 60. These are the factors for 60. Likewise, what is the factors for 84? We should list the factors for 84. 84 is divided by 1, divided by 2, it's divided by 3. Yeah, it's divided by 4. It's not divided by 5. It's divided by 6, my dear friends. You can see that it's divided by 6. Right, so yeah, 14 times. It's divided by 6, my dear friends. Then divide by 7, yes, 7, 12 times, right. So it's divided by 6, it's divided by 7. Is it divided by 8? No. Okay, 9, fine, no. We have to go for 10, 11, so then we have to go for 12, my dear friends. 12, 14. Then after that 14, we have 21. That you just check it out, my dear friends, we'll get 28. These are the factors. Yeah, 42. And then 84. Right, so likewise for 108, we have to find the factors. After all this, my dear friends, what is the highest common factor? Common factors are many. We should find the highest common factor. 108 is divided by 1, divided by 2, divided by 3, divided by 4. It's divided by 6. We'll get many factors here. It's divided by 6. Yeah, it's divided by 8. No, it's not divided by 8, right? So it's divided by 7. No, not possible. So 9. Yes, it's divided by 9. Then it's divided by 12, my dear friends. Yeah, it's divided by 12, right? Then it's divided by 18. Is it? So fine. Next, divide by 36. You just list out all the factors, my dear friends. 54 and 108. So I'm just mentioning all the factors for here. Maybe a few factors missed, okay, during this process. But guys, here first, what is the common factors? Common factors are common divisors. Common factors are common divisors. 1, 2, 3, 4 here, 1, 2, 3, 4 here, 1, 2, 3, 4. 6 is the one of the factor, 12 is one of the factor. After that, there is no common factors in all the three. It may be available in 2 numbers, but in all the 3, what's the next common factor is nothing. Highest common factor is 12 here. So we should write highest common factor is 12 or greatest common divisor is 12. HCF for 60, 84 and 108, finally we got 12, my dear friends. Right. This is one method where the basic meaning, okay, first calculate the factors, among common factors find the highest one, or calculate the divisors, among the common find the greatest one. Basic thing, right? So what is the alternate method? The next method, like we discussed in LCM, what we can do, write given number as prime number power. Write given number as prime number power, my dear friends. 60 is 12 into 5. 12 as 3 into 4. You can write this as 3 power 1 into 2 square into 5. Okay, so 12 into 5, 60. 84, 4 into 21, 4 means 2 square. 21 can be written as 3 into 7. Okay, that calculations you do it on, my dear friends. All things on paper will take more time. It will kill your time in exam. So you just do some calculation in your mind. 108, it's divided by 4, right? So yeah, 4 into 27, we can write 2 square into 3 cube. Okay, this is what? Writing every number as prime number power. Now, if you want to calculate HCF for this one, my dear friends, what you should do? So guys, now you should write only the prime numbers common in all. It's not like all prime numbers. In LCM, we're writing all prime numbers. Now here, we should write common prime numbers. Each prime number least power we have to write. What is the common prime number in all? 2 and 3 is there. Okay, 2 and 3 mention. Okay, 5 is not there in all. 7 is not there in all. 2 and 3 is available everywhere. And now we should take least powers of each one. 3, least power is 1. Don't take 3 cube. Least power of 3 is 1. Least power of 2. Everywhere 2 square only there. So 2 square. 4 into 3, 12. This is one more method, my dear friends, to calculate HCF. Highest common factor. Okay. So we should write given number as prime number power. After writing given number as prime number power, note down the common prime numbers available and least powers for that for HCF. Right. And one more method to calculate this HCF is, same example, 60, 84 and 108, my dear friends. See the differences. Difference here is 24, difference here is 24, difference here is 48. Difference here is 24, next one is 24, and here we have difference is 48. Now, take HCF for the differences, my dear friends. Take HCF for the differences. For 24, 24 and 48, HCF is 24. For 24, 24 and 48, HCF is nothing but 24 for us. Right. Now, this HCF for differences may be HCF for the given number. HCF for the differences may be HCF for the given number. But before concluding, I should check, is every number multiple of 24? 60 is not multiple of 24. 60 is not multiple of 24. Then what you should do, we should list out all the factors of 24 from highest to lowest. Okay, write down all the factors. For 24, 1, 2, 3, 4, 6, 8, 12 and 24. These are the factors for 24, right? Okay. 24 is not these numbers are not divided by 24, eliminated. Then we should try with 12. Yes, this number can be divided by 12. This number can be divided by 12. This is divided by 12. HCF is 12. If 12 fail, then go with 8. If not 6, if not 4, if not 3, if not 2, HCF for integers is minimum 1, my dear friends. HCF for integers is minimum 1. So we should write, first we will take difference between the numbers. Sometimes directly differences, these numbers are divided by HCF for differences. Some cases it may not satisfy. When it is not satisfied, go for the next factor. 24, next highest factor is 12. For that next is 8. Like that we have to check. Got it? Right. So these are different ways of solving HCF, my dear friends. This is all still basics. We'll go for the next level questions. And now, see, HCF for 60, 84 and 108 is 12. Right. What is this? Greatest number. This is nothing but greatest number which is divisible by greatest number which is divisible, or greatest number which divides, instead of divisible we should mention, which divides, greatest number which divides 60, 84 and 108. See, all these numbers are divided by this. We can verify the options. This point is required for you, my dear friends, to verify the options. Sometimes if options are given, I have to check, okay, this number is divided by my option. What is the highest number among the options? Okay, is all numbers are divided by that or not? I can check. Yeah, this should be divided by 12. Okay, if not, suppose I have some option here. Is that dividing 60 or not? If it is not dividing that 60, that is not my option. I can eliminate my option. You can eliminate options. Okay, you can verify. Yes, this all numbers should be divided by 12. Previously, while doing LCM, the result, this is divided by 10, 12 and 15. Now, this number is dividing this group in HCF. In LCM, this is like a group of numbers attacking 1. In LCM, group of numbers is attacking 1. And my dear friends, LCM of suppose A, B, C and D also, if it is available, is generally greater than given numbers. Equal also few cases, but in general, LCM if you do for the given numbers, it might be equal in few cases, but most of the time it's greater than the given numbers. Equal also possible, but most of the time greater than given numbers. And LCM is like group attacking 1. Okay, whereas if you see HCF, this one number is dividing this entire group. Here one number is dividing the group, their group of numbers is dividing 1. Okay, and here HCF of given numbers, for example X, Y, Z, is generally, okay, very rare cases it's equal, but in general it's less than the given numbers. It's less than the given numbers. Okay, whereas LCM is greater than the given numbers, most probably. Equal is very rare cases. Yeah, possibility is there. I don't deny that, but there is a possibility, less chances. Right. Now, let's go ahead with the questions, my dear friends, with these inputs. Previous questions given in SSC CGL, all those things. See the first question, my dear friends, P and Q is given. You should calculate LCM of P and Q. Okay, to reduce the burden for you, already everything is given in prime number power. Now, while doing LCM of P and Q, what you should do? LCM of P and Q. We should write all prime numbers involved. What are the prime numbers involved? 2, 3, 5, 7 involved. So mention 2, 3, 5, 7. Okay. Now, each prime number, highest power we should take 2, highest power is 5. For 3, highest power is 10. So 2 power 5, 3 power 10. For 5 and 7, only power is 1. It's not that its power is 1, we should consider. So your option should be D, right? 2 power 5, 3 power 10, 5 and 7. Okay, this is the first question, my dear friends, in today's exercise regarding basics. We'll go for applications and properties as well. See the next question, my dear friends. HCF of P and Q. HCF. Now for the same data, if you want to calculate HCF, what we should do? Write the common prime numbers. What is the common prime numbers in both 2 and 3 only? Okay, 2 and 3. What is the least powers of that? For 3, least power is 1. For 2, least power is 2 cube, right? So power 3. So your option should be B, my dear friends. Got it? Least powers, common prime numbers only we have to list out. Fine. This is basic questions. Now see the next question, my dear friends. We should calculate LCM of 57 and 93. Okay. 57 as a part of prime number, we can write 3 into 19. 93 is 3 into 31. Here 19 and 31, hope you know these are prime numbers. Now what we should do, write all the prime numbers and least powers for that. Prime numbers available is 3, 19 and 31. Yeah, least powers is nothing but 1, right? So now here, see, 3, check the units place first. 3 into, now or else here, I'll just writing the units place only. Okay, Or else you can find 3 into 31, 93, sir. 93 into 19. 3 into 9, your answer should end with 7. 3 into 9, 27, your answer must end with 7. Two options available, sir. Okay. A and B both are available. Now see, this product must and should be divided by 3, right? This is 3 multiple. My answer should be divided by 3. Now here I'll check with divisibility rule for 3. For divisibility rule, if you attend for the previous session number systems, we discussed, my dear friends, divisibility for rule is sum of digits. What is sum of digits? 6 plus 6, 12, 12 plus 7, 19. Sum of digits is 19, not divided by 3 waste. So this is your answer. Or else we given Vedic maths tricks for you, speed maths, how to do vertical cross multiplication. 93 into 19, you can do that product calculation also. Yeah, there are many ways to do, right? Or else this number is divided by 3. I'll check my options which is divided by 3. I said yes, this 57 is divided by 3. Okay, this is not divided by 3. Here sum of digits, if you just go 6 plus 6, 12, 12 plus 7, 19, not divided by 3. Here sum of digits, if you just check it out, 20, not divided by 3. Wow. Yeah, it's factors also. If this is divided by 3, my answer also should be divided by 3 when I'm taking LCM. It's only, this is the only option. Yeah, you can see sum of digits. What is sum of digits here, my dear friends? 21, right? It's divided by 3, right? You can apply that trick, my dear friends. There are many methods to solve. Okay, this is one way, and doing multiplication also we discussed, right? Now HCF of 57 and 513. Write given number as prime number power like that, or else your answer should divide 57. Your answer should divide 57. Your answer should divide 513, both numbers. 57 is not divided by 10. 57 is not divided by 10. 57 divided by 3, okay, but 57 is not divided by 27. 57 is not divided by 27. 27 2 is 54. 57, no. Okay, it may be 3 or 57. 3, yes, 57 is divided by 3, 3 19 times. Sum of digits here is 9 divided by 3, but you need HCF, highest common factor. 57 possible or not, we have to check first. Yeah, 57, this will divide 57. 513 is actually 57 into 9 times, right? So, both numbers are divided by 57. We should go with the highest, my dear friends. Highest common factor. So, 3 also divides both of this. Yes, agreed. That's not the highest common factor. One of the common factor, but highest common factor we require, we can go with 57, my dear friends. Clear? Okay. Now see the next question. Waiting for your answers, my dear friends. You can post your answers here. Now 4 numbers are involved. You have to find LCM for these 4 numbers. I'm just checking your responses, my dear friends. So guys, you can respond with your answers. What is LCM for 25, 30, 35 and 40? You can use different methods, whatever you have. LCM for 25, 30, 35 and 40. Right. Now, I can see this number is divided by 3. 30 is divided by 3 means my answer must and should be divided by 3. 30 is divided by 3. Your answer should be divided by 3, my dear friends. Here sum of digits is 5. Okay, waste, not divided by that. So we need sum of digits. Okay, divisibility by 3 rule is sum of digits we can apply. Okay, there are many methods. That's what depends on the given situation. Which one to apply, we can check it out. Sum of digits is 5. Here, sum of digits is 11. Option A. It's not divided by 3. This is sum of digits is 8. Not divided by 3. Sum of digits 6. This is divided by 3. This is one method. One method. As it is divided by 3, your answer should be divided by 3. So it's only 4,200 among the options which is divided by 3. Okay. No, sir, we'll go for the original method here. We can write 25 as 5 square. 30 as 2 into 3 into 5. Prime number power. 35 as 5 into 7. Prime number power. 40 as 5 into 2 cube, my dear friends. Right. See, now we know the methodology. Write all the prime numbers here, highest powers of each one. Now what you will get? Highest power of each one means 2 cube. Highest power of 2 available here is 2 cube. 3 is 1, 5 is 2. For 5, highest power is 2. For 7, highest power is 1. So I hope this is what? Yeah, 2, 3, 5, 7 involved. 3, highest power is 1, 5, highest power 2, 7 like this. Now 8 into 25, 200. 8 into 25, we got 200. 3 into 7, 21. 2 into 21, 42. And this is 4,200. See this. One using verification, one using factorization. Okay, we had to write prime number powers. Prime factorization we had to do. Right. See the next question, my dear friends. HCF for 3 numbers. This is basic questions. Slowly we'll go for the next level. First we should be good in the basics, my dear friends. Again, this one what you can do, we given one method like take difference between numbers. Difference here is 38. Difference here is 38. Difference here is 76, my dear friends. Difference here is 38. Difference here is 38. Difference here is 76. Yeah, HCF for the differences are, see, one more point you should keep in mind. Your answers should divide the difference also. It's not only, okay, to verify each and every number may be time taken. You can check here, your answers should divide the differences also. Difference between numbers also you can check. 44 is not dividing 38. 44 is not dividing 38, not required. 38 cannot divide 21. This, 38 should be divided by 44, no. Is it divided by 21? No. It's divided by 19 and 38 both. Sir, is it 19 or 38? 19 if there is any odd number. 19 if there is an odd number. But all are even numbers. You will get 38 here. If you check it out, this is 38. HCF for the difference is also 38. And directly for the given question, 38, 38 and 76 will get 38, my dear friends. And you can see every number can be written as 38 multiple. This is 38 2 times. This is 38 3 times. And this is 38 4 times. Every number we can write it like 38 multiple. Yeah, fine, we can find HCF is 38 here. 19 also satisfied, but that is not the highest common factor. One of the common factor, not highest one. Right, now we'll go for fraction, my dear friends, x by y format. Now what you have to do, LCM for the fractions, if suppose it is like p by a and q, p by q and x by y for example, you should do LCM for numerator values and we should perform HCF for denominator values, my dear friends. LCM for numerator and HCF for the denominator we have to perform. When it is for fraction, apply LCM for numerator, my dear friends, and HCF for the denominator values. Here numerator values are 2, 4, 5, 7. So we should calculate LCM for 2, 4, 5, 7. Denominator values is 3, 9, 6. 3, 9, 6 and 12. Yeah, we can understand 3 is the HCF for the given numbers. Yes, all are 3 multiples. Least value is 3. We got yes 3. Here 2 and 4. When 2 and 4 is the 2 not required. It's already 2 square, right? So 2 square into 5 into 7. 20 into 7 will get 140. So answer is actually 140 divided by 3, my dear friends. LCM for 2, 4, 5 and 7, if you perform, will get 140. Here 2 is not required. 2 square, highest power of 2, 2 square, 5 and 7. 2 square into 5 into 7 will get 140. Okay. And here HCF is 3. So when you do LCM for fractions, apply LCM for the numerator values and HCF for the denominator values, my dear friends. LCM, this is LCM for fractions. And next one, how to apply HCF for fractions as well. LCM for fractions. Then we'll go for decimals as well. This is regarding fractions. Next, one example regarding HCF for fractions. here what you should do, when you want to apply HCF for the fractions, my dear friends, you should apply HCF for numerator values and LCM for denominator values, my dear friends. HCF for numerator values, numerator are 4, 6 and 8, and LCM for the denominator values 5, 8 and 25. Right. So guys, when you do HCF, we can clearly understand it's 2. 4, 6 and 8. Yeah, 2 square, 2 into 3, 2 cube. Okay, what is the common primer involved in all is 2 only. Least power is 2. And here, when you want to go for HCF, it's 8 into 25. We'll get 200 in the denominator, is it? Okay, 2 cube. Highest power of 2 is 2 cube. Highest power of 5 is 5 square. So we'll get it like finally 1 by 100, my dear friends. 1 divided by 100. Okay, so option A, HCF for the fractions. Here we're discussing with examples, my dear friends. Okay, instead of giving you already the formulas and all, so we'll discuss with example. When it is fraction part, apply HCF for numerator and LCM for the denominator. Now, we'll go for decimal part, my dear friends. Okay, how to do LCM for decimals? Yes, it is. How to apply LCM for decimals and HCF next example. Now listen, when you want to do this decimals, first you convert that as x by y format, fraction. 1.08, we can write this as 108 divided by 100. And when you write x by y format, make sure there is no common terms in numerator and denominator. Okay, we should cancel the terms. Yeah, this is 427 times, this is 425 times. Next, 0.36 in similar way is 36 by 100, my dear friends. When you cancel the common terms, this is 4 9s, 425s. Similarly, 0.9 as 9 by 10, there is no common thing in numerator and denominator, let it be. Now, you have to apply HCF for this fractions now. Okay, this is now fraction part. HCF for 27 by 25 and here 9 with respect to 25 and 9 with respect to 10. Apply HCF for numerator values and sorry, we are calculating LCM, right? Sorry guys, yeah. That is the case, we have to apply LCM for the numerator and HCF for the LCM for the fraction, my dear friends. Apply LCM for the numerator and HCF for the denominator values. Yeah, we have 25, 25 and 10. Now, 3 cube, 3 square, 3 square. 3 cube is the LCM, 27. If you do HCF, 25, 25 and 10, 5, right? So if you just do this, my dear friends, we got 5.4. 5.4. This is the method, or else other one what you can do. Okay, this is yes basic method how to do. Okay, with the original method how to do it for decimal part, convert into fraction. Then LCM for fractions how to apply, we know in previous question. We can apply that. The other strategy what you can do, this answer should be divided by 1.08. It's not like decimal now 1.08 into 5. That should be like into 5 into 6, like that we require. 1.08 5 times is 5.4. 5 times, my dear friends. And 0.9 6 times is 5.4. It should be like an integer. We should multiply with an integer. Okay, this should be divided, or else we discussed this 5.4 should be divisible by these numbers. It should be divisible by these numbers. Right. So like that you should check with that aspect also. Yes, this is into 5 times, this is into 6 times, this is 15 times. 36, 15 times we'll get. Okay, so 0.36 into 15. I mean to say 0.36 into 15 will give 5.4. Like that also you can verify. Okay, there are n number of methods, my dear friends, to do the question. Right. Now, let's try this question. You have to convert this decimal part to fraction. Okay, once that is converted into fraction, you just try to apply HCF for the fractions. Meanwhile, I'll check your responses, my dear friends. Yeah, Dinesh, I'll go through that. Can you mention, Dinesh, what is the exact question you have a doubt? Question not visible correctly. Okay. Thanks for the update, Akhil. Here, if you want to do for the decimal part, first what we should do? We should convert that into fraction. 0.8 as 8 by 10. Don't maintain any common terms here. Make sure there is no common term in numerator and denominator. And 0.125 is 1 by 8 in percentages. Topic, or else okay, we can write 125 divided by 1000. We can write this as 1 by 8. And 0.625 is obviously 5 times this one, right? We can write directly 5 by 8. 125, 5 times 625, right? So 5 by 8 we can write. And 0.5 is nothing but 1 by 2, my dear friends, right? So this is how you converted the given decimals into fraction. Now you have to apply HCF here. So you apply HCF here, my dear friends. HCF for this all fractions. HCF for 4 by 5, HCF for 1 by 8, 5 by 8 and 1 by 2 for all this. Yeah, what you should do, HCF for the numerator, 4, 1, 5 and 1, and LCM for the denominator values, 5, 8, 8 and 2, my dear friends. See, when 1 is there, HCF is 1 only. When 1 is involved in values, okay, HCF is 1, we cannot go beyond that. Whereas 5 and 8, or 2 I can ignore, okay, as 8 is available. For 5 and 8, LCM is 40. 1 divided by 40, my dear friends, option B. 1 divided by 40, option B, my dear friends. This is how you should apply HCF for the decimals, my dear friends. Clear? Okay. Now see the last question related to basics, my dear friends. In previous CGL, SSC CGL exam, they given this question already. Least common multiple for 1728 and K, they given the value of this is nothing but 5184. They given LCM for 1728 and K is nothing but 5124. Now question is, what's the different values of K is possible? How many different values for K are possible? How many different values we can take for K? Still the result should not disturb. The result is already given as 5184, right? My dear friends, say this, 1728 is nothing but 12 cube actually. Write it like prime number power, prime number power. 12 is 3 into 4. 4 means 2 square. I can write this as 3 cube into 2 power 6. I hope you agree with that. Okay. If you just write this as a prime number power, my dear friends, yeah, 1728 is 12 cube. We can write this as 3 cube into 2 power 6. Okay, 1728. What is the result here? What is the result? 5184. This is 1728 into 3. Means here in the result you have 3 power 4 and 2 power 6. 3 extra is there. This is the result you want. And if you just recall how to do LCM for two numbers, what are they given? We should write all the prime numbers involved and highest powers of each one, right? Highest powers of each one. Now see, already 1728, 3 power 3 only available, but in the result 3 power 4 is there. In the result 3 power 4 is there. So K must and should have 3 power 4. 3 power 4. The other numbers don't involve 5 and all. If you involve 5, 5 should be there. What is the rule for LCM? Write all prime numbers involved. Here prime numbers involved is 2 and 3 only. I cannot go with other numbers. Here I can write 3 power 4. One possibility. Still my result will not disturb. K can be 3 power 4 into 2 power 1. K can be 3 power 4 into 2 square. K can be taken as 3 power 4 into 2 cube and 3 power 4 into 2 power 4. Sir, up to what? Up to 2 power 6. If it is 2 power 7 here in this also 2 power 7 required. So I cannot go beyond 2%. So this 1, 2, 3, 4, 5, 6, this is 2 power 5, up to the 6 numbers are possible. Now 7 numbers are possible, my dear friends. So up to here we can go ahead. So understand this methodology, my dear friends. How many different values are possible is nothing but we have 7 numbers are possible. See the list of all these numbers which is possible for k. We can take k is nothing but 3 power 4 you can consider k is 3 power 4 into 2 power 1 up to 2 power 6, sorry, up to 2 power 6 we should consider. Up to 2 power 6 we should consider, my dear friends. Right. Now let's see the next properties related to this LCM and HCF, my dear friends. Yeah, these are the different values of k. Is this okay? Fine, let me check your responses, whether you understand this or not. Dinesh, in that question, what you mentioned 30, see, that's what the property, my dear friend, okay? That's what by experience you will get the idea. So why you chosen 30 only divided by 3? Yeah, see, remaining numbers are 5 multiples. All options are 5 multiples here. All options are 5 multiples. Okay, so that's what by experience you will get the idea, my dear friend, why I am choosing 30 divided by 3. See, in general, divisibility rules, which is useful going forward is 3, 9. 4, 8, those things will useful. So I'm just checking always for 3 and 9. That will help you to sort it out the answer easily. That's one methodology. This is the update. Going forward, you can see some exam. You can also do like this, right? We're giving you other methodology as well. Okay, depends on the given number. Sometimes I can go divide by 9 also if 36 involved. 3 and 9 will help you to get the answer very fastly, my dear friends, to verify the options. Okay. Now let's go for the properties, my dear friends. Hope you understand 7 numbers here. Okay, possible for k. Now LCM and HCF, first property, very simple property. LCM must be divisible for the same number. Suppose you take an A, B, C, okay, or maybe A, B, C, D like that, is definitely divisible by HCF. LCM is definitely divisible by HCF for the same numbers. If we take same numbers, yes, for the same numbers perform LCM and HCF, definitely LCM is divisible by HCF. Okay, if somewhere they given without this rule, that question itself is wrong. Okay, this must and should satisfy. LCM is definitely divisible by HCF. Take small number. Okay, let's consider I am taking HCF for 8 and 10. For 8 and 10, HCF is nothing but equal to 2. What is LCM for 8 and 10? Is nothing but 40, right? It's definitely divisible. LCM is divisible by HCF. Or else you know, right, what every number we're writing as prime number power, all prime numbers involved in 2 highest powers in LCM. All prime numbers involved in LCM with highest power. In HCF, common prime numbers for the same numbers involved with least power. So definitely it's divisible, right? There is no second thought, my dear friends. Okay, just I'm giving you an example here, but you can understand that. See, 2 questions related to that is HCF of 2 numbers is given as 8. HCF of 2 numbers is 8. Which one of the following can never be LCM? LCM which cannot be. See, LCM must and should be 8 multiple. 8 multiple which can never be 60. LCM must be, as HCF is 8, LCM for the same numbers must be 8 multiples. Must be 8 multiples. Okay, if 60 is not possible. Right, so that's what the property LCM must and should be divisible by HCF. Right. So the next question, LCM is given for 3 different numbers. Let's call like A, B, C, my dear friends, 120. HCF, what should be the HCF? HCF should be divisible, okay, the numbers which is dividing 120 are factors of 120 I can call. Okay, HCF must and should divide LCM, right? Means HCF is a factors of 120, divisors of 120, factors of 120. HCF must and should divide 120. So yeah, 120 is divided by 8 15 times, 120 divided by 12, 120 is divided by 24, 24 5 times 120. We cannot go with 35, my dear friends. 35, yeah, 120 is not divided by 35. It's not a factor of 120 also. Right, so LCM must and should be divisible by HCF, my dear friends. This is regarding that property, first property, 2 questions, right. Now say the second property, my dear friends, very important property. This is applicable only for 2 numbers. For any 2 numbers, let's say A and B, this is applicable only for 2 numbers, my dear friends. For any 2 numbers, let's call A and B. Product of 2 numbers A into B must be equal to LCM and HCF products. Product of 2 numbers must be equal to LCM and HCF product, my dear friends. Yeah, product of 2 numbers is nothing but equal to LCM and HCF product. For those numbers, we should calculate LCM and HCF. So LCM and HCF product, or product of LCM and HCF. This property, you just check it out, my dear. For any 2 numbers, this is only for 2 numbers. Keep in mind, don't apply this for 3 numbers and all. This is only for 2 numbers. Not applicable for 3 numbers. For any 2 numbers, product of 2 numbers must be equal to LCM and HCF. Yeah, just now we discussed one example. I taken A value 8, B value 10. We calculated all the HCF for 8 and 10 as 2, and LCM for 8 and 10 is nothing but 40. Right. Now here, product of 2 numbers A into B, you check it out. Yes, A is 8, B is 10. Product of 2 numbers 80 is nothing but LCM and HCF product. Nearly we have more than 10 questions related to this second property alone, my dear friends. You can understand the importance of this. They are giving variety of questions here related to this property. You may think this is very simple, but there are a lot of properties given. Yes, LCM is nothing but 40, HCF is 2. Yes, both 80 and 80 here are equal. So guys, keep in mind, yes, product of 2 numbers is nothing but equal to LCM and HCF product. For any 2 numbers, let's say A and B, product of 2 numbers must be equal to LCM and HCF product. Right. Now see the first question related to that, my dear friends. This is one of the previous question in SSC. 2 numbers product is given. A into B is given. HCF is given. You should calculate LCM. Now see this, my dear friends. These 2 numbers product is 45,360 is mentioned. Okay. LCM you have to calculate. HCF is nothing but 36. Now listen, sir, this big term we had to cancel and checked out what is the answer. Time waste, don't do that. Okay, don't try to divide all those things. Now what I'll do, I'll check the option. I'll check with the option. I have to end with 0. This answer product should end with 0, means this LCM should end with 5 or end with 0. Because 6 into 5 will end with 0, or 6 into 0 should end with 0. My answer should end with 0. These 2 options are eliminated. My answer should end with 0. Okay. Next, I'll check it out. 630 into 36 is one possibility. Other one, 1260 into 36, right? Here, ending with 0, okay. Next one, 3 into 6 is 18. Here we will get 8. Whereas 6 into 6 is 36, we will get 6 here. See the options, my dear friends. We are verifying these options now. I'm just trying to check which is possible. See, ending with, after 0 we want 6, not 8. So this is eliminated. I can go with D. Sir, better than this I can cancel. It's your wish, guys. We are not denying that. We are giving you multiple methods to save that time. Sir, I can divide with 36. Yeah, 36 one time. 1 required. Yes, that's also okay, fine. Ending with 0 required. 36 one time, 36 are 9 remainder. Okay, sir, 1, starting with 1, 2 options. But we need a product should end with 0, means this LCM should end with 5 or end with 0. Ending with 5, no option, ending with 0. That's also okay here. There are n number of methods we can do. Yeah, 36, one time that, like that you can verify which option is okay, which option we can eliminate. That calculations is badly required here. Now see the next question. HCF is given, LCM is given, one of the numbers is given, you should calculate the other number. Again, product of, this is only for two numbers, you please check that, okay. Now here, LCM is 6, HCF is 5040, LCM is 6, one of the number is given 210, we should calculate the other number. Right. Now see this, my dear friends, what I will do, yeah, this result, if you multiply this, or maybe some people will try to cancel this or multiply this, there are many methods. What I will do, I will again cross verify my options. Okay, so what I can say, here, this is ending with 0, 6 4s are 24. My result, if you multiply this, 6 into 0, okay, that's 0 now will come. 6 into 4 is 24. I have to get 0 and 4. Here also already 0 is confirmed. Because of 210, 0 confirmed. Here some number in B, multiplying with 1 should end with 4 means B should have 4 in that. That's there only in 144. I am doing always that verification way, my difference. 144 if you put it here, 0, 1 into 4 will be 4 here. Then only this will satisfy in this right side. Sir, I will cancel the terms. Yes, your wish, you can do, no problem. But there are n number of methods. This is what, okay, we got 144, my dear friends. We don't have any option with 4 there. Right, so if it is 144, yes, 0, 4 into 1 will be 4. Here, 6 into 4 is 24, 4. Like that you can verify also, my dear friends. Now, one important point, one very important point. Two numbers are called co-primes if HCF is 1. A and B not mandatory prime numbers. If two numbers HCF is 1, then A and B are co-primes. A and B are co-primes. If HCF for two numbers are 1, then A and B are called co-primes. A and B may be prime numbers, may not be also, no problem. Okay, it's not mandatory, it must be prime number. No, not mandatory. Not mandatory, my dear friends. Suppose 9 and 13, 9 is not prime number. But if you take HCF for 9 and 13, we will get 1 only. Okay, 9 and 13 are co-primes. 9 and 10 are not prime numbers, but if you take HCF for 9 and 10, it's 1, 9 and 10 are co-primes. It's not mandatory, A and B must, yeah, prime numbers also okay. It's not mandatory, A and B must be prime number. Without prime numbers also co-primes possible. Okay, so co-primes are nothing but, if HCF for two numbers is 1, then we call it like a co-primes. Right, now here, product of two co-primes is 117. So, product of these two is 117, and we know for co-prime numbers HCF is 1. Okay, this product is 117. Must and should be LCM is also 117. For co-primes, LCM equal to product of the numbers because HCF is 1. For co-primes, HCF 1, definitely LCM is equal to product of the given numbers, my dear friends. Clear? Now see the next question. See the next question. LCM of two numbers is given, HCF is given, difference between the numbers is mentioned. What is the sum of the numbers? Listen, my dear friends. There are 2 to 3 methods to solve this question. We'll discuss 2 methods now. See, LCM is given, HCF is given. From that I can calculate product of the numbers. A into B is nothing but LCM into HCF. We can say it's nothing but 168 into 12. Okay, A into B is nothing but 168 into 12. Difference between the numbers A minus B is given as 60. But this will take more time, my dear friends. I'll give the alternate, but this is method 1. Method 1. You know A into B. You know difference between the numbers A minus B. Now they're asking A plus B. So how to calculate A plus B when you know these two parameters is, yeah, you can do square root of A minus B whole square plus 4AB. This is one method. Other method which is bit easy to solve, we'll go ahead with that. This is one method, my dear friends, where you can do, yes, A into B is given, A minus B is given. You had to calculate A plus B. Sir, I know A plus B whole square formula, okay, in terms of A minus B and AB is this. We can substitute that, okay, but it will take more time, right? 60 square, 4 into 168 into 12 will take more time, my dear friends. This is one method. What is the other method? You can write HCF for two numbers is 12. Means those two numbers, let it be A, is nothing but 12x, 12 multiple. B must be 12 multiple. The two numbers must be 12 multiple. Yeah, because they mentioned, right? Yeah, HCF is 12, means those two numbers are 12 multiples. 12 into something, 12 into something. And now LCM is 168 for these two numbers. Say this, LCM is 168 for these numbers means it's 12 into LCM of x and y is nothing but 168. I can say this is 14. And here x and y must be co-primes. Listen, what's the problem? If x and y are not co-primes, if there is some common factor in these two, then what will happen? Here, HCF will not become 12, it may be more than that. This point you should be concentrate, my dear friends. See the shortcut and understand this methodology. A is 12x, B is 12y. How you write, sir? Two numbers. Have you written 12x and 12y is? HCF is 12. So the two numbers are 12 multiples. Clear? So 12x and 12y. Highest common factor is 12. So among x and y, there is no common numbers. Okay, HCF for x and y is must and should be 1. Otherwise, what will happen? If x and y there is something 2 multiple both are means, then HCF should be this original number, HCF should be 24. So you just focus, my dear friends. Okay, for x and y, there is common factor is nothing. LCM is definitely x into y only product, that is, this is directly product only. These two are co-primes. See, when you are doing LCM of A and B with common factor 12, you divide with 12, then this, what are the two numbers left over? Okay, when it is only two numbers, HCF for that is 1 for sure. This is nothing but x into y is 14. And in question, see, keep that x into y is 14. And in question, difference between two numbers is 60. Two numbers means A and B. This is 1 point. Here, many people may have doubt. Again, I'll get back to that. See, A minus B is 60. A is 12x, B is 12y. It should be divided by 12 means x minus y is nothing but 5. Divide by 12, my dear friends, x minus 5 is 5. Now, check it out. Two numbers product is 14. Two numbers difference is 5. It is 7 and 2. 7 2s are 14. 7 minus 2 is 5. 7 2s are 14. 7 and minus 2 is nothing but 5. Here I came to know from these two analysis, my dear friends, when you analyze these two, I came to know x is nothing but 7, y is 2. Then what you want? Sum of the numbers, right? A plus b, which is 12x plus 12y, 12 into x plus y. I know x is nothing but 7, y is nothing but 2. If we do, we'll get 12 into 9, 108, my dear friends. This is easy method compared to first one. But method 2, if you want to understand, okay, focus here, my dear friends. LCM for A and B 168, as 12 is common, I'm putting the 12 out, okay. Then x and y LCM we should do, okay. And for for x and y, HCF must and should be 1. Otherwise, okay, here this 12 will not be satisfied. So this is indirectly product of two numbers is nothing but 14. Okay, and here difference between two numbers is 5. Now we can analyze as it is small numbers. Two numbers product is 14, two numbers difference is 5. Okay, like that you can go. Many more questions are followed. You can understand one by one, my dear friends. Next step examples going forward, you can understand this. We'll apply this only. And here I hope understand this is lengthy method. We can apply this, but lengthy, right? Why worrying about this big calculations? Okay. See one more question, my dear friends. After that, we'll take break. Okay, see the next question. Here, two numbers ratio is given. Means first number may be, I can take like 7k, second number may be like 13k. Their HCF is 8 means HCF for A and B is nothing but k. They are given k is nothing but 8. This is nothing but k only. K is given as 8. Now they're asking LCM. See, this is what actually happened in the previous question. Now that's what I want to explain you here. Two numbers ratio is 7:13. Okay, 7k and 13k they are. Their HCF is 8. Means here k is the HCF. K is nothing but 8. Now here what they're asking, my dear friends, LCM for these two numbers. LCM for 7k and 13k. Now listen, what you should do actually, okay, that k you can put it out. It's like LCM for 7 and 13. K is nothing but 8. For 7 and 13, LCM is 7 into 13 only 91. This is what happened previous one also. That K I taken out. You can see here that K we taken out. Nothing but HCF. 12 is taken out. And two numbers what were left out for remaining. Okay, this is 12x and 12y. The 12y taken out. For x and y did LCM. That's almost like product. When you have two numbers, it's like product of those two. Now here, yes, it's like product of 7 and 13, 91. It's all together 728, my dear friends. Okay, this point I think you are still worrying about. Okay, how you got this two numbers product and how you taken k out. Or else you can work on it, my dear friends. You substitute k value. This is 7 into 8. This is 13 into 8. You can do LCM for that. Still we got 8, which is common in both. We can take that out. For 7 and 13 LCM 91, we'll get 728 only. Okay, going forward with a few more examples, you will get better clarity, my dear friends. But for a while, take a break and refresh your minds, my dear friends. Join after 2 or 3 minutes. Okay. Let's go to the next question, my dear friends. So this next question, two numbers are in the ratio 7:11. If their HCF is 28, then the difference between the two numbers is what? It's similar to previous question. We calculated sum of LCM, okay, fine. But here they're asking to take difference between the two numbers. Very easy question this is. They given HCF is 28, right? Yeah, two numbers is what? 7k and 11k. Okay, other number we can take, one is A is 7k, the other number B we can consider like 11k, my dear friends. Here they mentioned HCF is 28, means k is nothing but 28. They given in the question HCF for these two numbers is k, that's nothing but 28. Now they're asking difference between the numbers. What's the difference between the numbers is nothing but 4k, which is 4 into 28 directly. Right, which is 112, option C. Easy question this is. Difference between the two numbers. Okay, HCF is given, you know two numbers values directly. Okay, 7 into 8, 7 into 28, 11 into 28. Directly we can do 4 into 28. Next question, you should take hardly 30 seconds, my dear friends. See the next one. They are asking sum of the two numbers. They given HCF already. What is sum of these two numbers? 11k. K is already given. That k is nothing but HCF. Okay, that common factor HCF is given. So it should be 11 into 26. Right, so they're asking sum, which is nothing but 11k, my dear friends. We already given you how to handle this 11 multiple. Right, so option D, check it out once. Two numbers are in the ratio 4:7. Sum of those two numbers, that HCF is given already. HCF is 26, so we can take it directly 26. 4 plus 7, 11k. K value is nothing but 26 here. HCF. Got it? Now see the next question. Now LCM is given. Previous one, HCF is given. Now LCM is given. Fine, no problem. Numbers 2k and 3k. What is LCM for these two? K, you should put it out, right? LCM for A and B is nothing but 54. Here when you take LCM, this K is common, that K you should put it out. So LCM for 2 and 3. When you take LCM for A and B, as K is common, that K will be out. For 2 and 3 we should apply LCM. Simple logic is that. Now here LCM for 2 and 3 is 6. We can find K is nothing but 9. Now question is regarding sum of the two numbers, which is 5k. 2k plus 3k, 5k. You know k value 9, we'll get it like 45, my dear friends. Now LCM is given, previously HCF is given. I hope you are getting the clarity for this question now. This lengthy question, whatever we discussed long back. Okay, this calculations, initially you may have some doubt in your mind. Sir, have you taken this product? This part especially. I think this is clear for you. This part is where people are struggling to understand. Now I hope you got the clarity. How we got this? X into Y is 14. Okay. See the next question, my dear friends. Ratio related right now. Here HCF is given as 12 for 2, 3, 4. Meaning what are the three numbers? A is 2 into 12. B is 3 into 12. C is 4 into 12. Now we have to calculate the LCM for those three numbers. Okay, as we discussed, the 12 we should put it out. You take LCM for 2, 3, 4. This is the short way, my dear friends. No, sir. This is 24. This is 36, 48. For that only we will do. You do that also, same thing will happen. Okay, the short method to go ahead here is, yes, take the 12, which is HCF, put it out. Take for LCM for this 2, 3 and 4. For 2, 3 and 4, LCM is nothing but 12. We'll get 144, my dear friends. We'll get 144. Take the 12 out, or else, yes, we can find, or else check it out. Okay, these are the numbers, right? We have to write, when you're calculating LCM, highest all prime numbers we have to involve. What is the prime numbers involved? 12 also, 2 and 3. All are 12, 2 and 3 only. Highest power of 2 will be obtained here, 4 and 4. 2 power 4 will come. No, I'm just giving you the other method what you can do, 2 power 4. Highest power of 3 available here. 12 is 3 into 4. Here 3 square will come. Writing given numbers as prime number power. Here this is 2 cube into 3 power 1. This is 3 square into 2 square. This is 2 power 4 into 3. Right. Now, while taking LCM, write all prime numbers. All prime numbers are 2 and 3 only. Highest powers of each one. Highest power for 2 is 4. Highest power for 3 is 2. See, you got same thing, my dear friends. 144 only. Instead of that, 234 LCM is easy, right? Okay, so whatever it is convenient for you, you can apply. This is what the short way we can do. Take that HCF one out and do LCM for the remaining ratio part, whatever they mention. Directly you can do, yes, 12 into LCM for this ratio part. Clear? Now see the next question, again related to ratio, my dear friends. Now you should speed up. LCM is 1800 they given. It's nothing but HCF, consider it is like equal to K. Then LCM they given us 1800 for those 3 numbers. Means what I can write, this is K into LCM for 3, 4 and 5. K into LCM for 3, 4 and 5. LCM for 3, 4 and 5, as all numbers are different, we'll get product of that only 60. So we have to calculate K value, my dear friends, here. This is K multiplied with something. So here we should calculate K. If you calculate K, my dear friends, this is 1800 divided by 60. We got 30 here. K value is 30. Now what is the question? Second number. Second number is 4K. 4 into 30. Or I'll see the shortcut actually. No need to do all these things. Your answer should be divided by 4. The very simple method. Second number is 4 multiple. You check which option is divided by 4. This is not divided by 4. It should be 4 multiple. This is not divided by 4. Other method 2 is this. So why you are dividing with 4? Second number is 4 multiple. It should be divided by 4. Only one option divided by 4. There are many methods, my dear friends, to go ahead. Got it? Superb. Now see, still that property 2 related questions. Okay, and related to ratios. Okay, it's not only regarding that property 2. Okay, regarding 2 numbers or 3 numbers, LCM HCF related questions we are discussing. Then we'll go for applications once we are done with this, my dear friends. See this question. Sum of 2 positive numbers is 240. This is previous CGL question. SSC CGL previous paper given in 2019. Sum of 2 positive numbers is 240 and their HCF is 15. Now what are the 2 numbers we have to write down? A is 15x, B is 15y, HCF is 15. So those 2 numbers must be 15 multiples. Got the clarity? And they given A plus B is 240. So why you taken 15x, 15y? HCF for the 2 numbers is 15. So it should be 15 multiple. Now sum of the 2 numbers is 240. So it should be divided by 15. 15 is common, right? X plus y, 240 divided by 15, if you do, my dear friends, we'll get 16, sir. Okay, fine, cool. Is it 16? Yeah, fine. X plus y is 16. Now what is the question? X plus y 16, how many such pairs are there? How many pairs are there satisfying the condition? Sir, x plus y 16 means x value 1, y value 15, x value 2, y value 14. Don't take all numbers. X plus y 16, but you should not disturb. You should not disturb HCF 15, my dear friends. HCF should not disturb. Means what are the numbers you are taking x and y? X and y must be co-primes. So guys, keep in mind HCF must be, x and y must be co-primes. Otherwise, this HCF 15 will disturb. Okay, x plus y 16 you require, okay. What is the values you can take? Is 1 and 15. Yeah, 1 plus 15, 16, okay. But don't take 2 and 14. For 2 and 14, HCF is 2. Okay, that 2 will, then HCF is not 15, 30 it become. Problem will be there, this will not satisfy. So these 2 must be co-primes. Okay, don't take 2 and 14. 3 and 13, okay, 3 plus 13 is 16. Okay, satisfying that pair. 4 and 12 not okay. 4 and 12 no. 5 and 11 is okay, fine. Then 6 as well as 10, no, not satisfied. 7 and 9 is okay, fine, 7 and 9. 8 and 8 not okay, then again 9 and 7 means no. 7 and 9, 9 and 7 same only. Okay, we have only 4 pairs satisfying. It's not 8, my dear friends, 4 only. Don't take again. So 1 and 15, 15 and 1. Numbers are same, right? Okay, the two numbers are okay. A plus B or B plus A, both same. A into B, B into A, same. So don't again change it like 15 and 1, 3 and 13, 13 and 3. Okay, these are the 4. Why not remaining? I hope you got the clarity by this time. If you have other two numbers, 2 and 14, if you take, those are not co-primes, 2 and 14. What will happen? That will disturb your HCF, my dear friends. So keep in mind, while taking numbers, you must and should think about it. Okay? Now, one more question, previous question in CGL, slight update. Here's sum. Let's take now product. Product of two numbers. Previous question. Okay. A into B. HCF is 13, they clearly mentioned. So the numbers are 13x and 13y, and must and should be x and y are co-primes. X and y are co-primes. Otherwise, HCF 13 is wrong point. X and y must be co-primes, otherwise HCF will be disturbed. Okay, now product of two numbers is 6,760. So you just check it out. Yeah, A into B is 6,760. You should divide. This is x into y now. Two numbers product. You should divide with 13 two times. First time it's 520 because 13 5s, 26, 260 means you have 520. Again, if we divide by 13, we'll get 40. So how many pairs are there satisfying this? How many pairs of numbers are satisfying? X into y is 40. Again, keep in mind, x and y are co-primes, my dear friends. Now say this, product of two numbers 40, satisfying co-primes is how many pairs? 1 and 40 are okay. 2 and 20, HCF is not 1, so don't take 2 and 20, they are not co-primes. 3, 40 is not 3 multiple. Then 4 and 10, no. 5 and 8, okay. Don't take 8 and 5, again same thing. 5 and 8. 6, no. 7, no. These are the only two pairs satisfying, my dear friends. Okay, so answer is 2. How many such pairs are satisfying? Okay, product of two numbers and HCF they given. Okay, how many are sum of two numbers HCF given or product of two numbers HCF is given? How many pairs satisfying is only 2 here. And previous one, yes, we have 4 such pairs at least, but here we have only 2. And a lot of people are doing that mistake, going with 4, taking 1 and 40, 40 and 1. No, don't take again. Okay, 1 and 40 as 40 and 1, it's waste of time. Now see this question, my dear friends, bit similar to previous one. Now here, they given one of the numbers lies between 200 and 300, then sum of the digits of the other number. If other number is given, we can do option verification. So they are also smart enough now. Okay, while studying the paper, they are giving sum of the digits of the other number. They are asking sum of the digits, my dear friends. Now see here, HCF of two numbers is 21 and their LCM is 221 times the HCF. If one of the numbers lies between 200 and 300, then sum of the digits of the other number. Now listen, yeah, HCF is 21. I can take first number is 21x, second number is 21y. LCM they given in the question is 221 times the HCF. HCF is already 21, right? Now here, what is LCM of these two numbers? What is LCM of these two numbers is 21 into LCM of x and y is nothing but 221 into 21. Here 21, 21 cancel. We know x and y are co-primes. X and y must be co-primes. X and y must be co-primes, my dear friends. Okay, so here this LCM is now, when x and y are co-primes, it's like product 221. Only one thing satisfying this product is, yeah, two pairs satisfying is, one is 1 and 221, other one is 13 and 17. Only two pairs satisfying this is x value 1 and y value 221, or x value 13, y value 17, and vice versa. Okay, so 17, 13, 221 and 1, vice versa we can take, my dear friends. Okay, but see, your two numbers product, this is the two values satisfying the two pairs. But now to sort it out, they given one number lies between 200 and 300. Now listen, suppose if you go with the first one, my dear friends, first number is 21 into 1. Second number 21 into 221, it not lies between 200 and 300. We need the number should lies between 200 and 300. If I take this first pair, first number is 21, other number is 21 into 221, which is a big number. It not lies between 200 and 300. So which pair they are discussing about is second pair only. Okay, what are the numbers now? A is 21 into 13, which is nothing but 273. Yes, it lies between 200 and 300. They're asking about B now. B is 21 into 17, which is 357. Sum of these digits they're asking. Sum of this is nothing but 15, my dear friends. So answer is 15. Sum of the digits they're asking. The other number is 357, and sum of those digits is nothing but 15, my dear friends. So this question, okay, so we have product of two numbers. Now we decided in previous two question how many pairs are possible. Now in this question you are filtering that. Okay, among two pairs we are filtering, okay, which one is suitable. They given a clue for that. This is previous CGL question. They given a clue for us how to filter. Okay, one of the numbers lies between 200 and 300, my dear friends. With that we can filter 1 and 221 is not possible. This is one of the pair satisfying this condition, but there is one more condition. One number lies between 200 and 300 is not possible. If we go with 1 and 221 pair, we should go with 13 and 17. Right. So guys, let's see about this next question. This is also previous question given in CGL. LCM of two numbers x and y is 204 times their HCF. HCF is 12. Here x and y is given. I cannot take now a and b. Let's take x and y is the numbers. Okay, x is nothing but 12 multiple. Let it be like now 12a or 12l. Y is nothing but 12m. Two numbers x and y. Okay, as I mentioned, HCF is 12. Okay, and now LCM of two numbers x and y is 204 times the HCF, means it's indirectly L into m is nothing but 204. L into m is 204. That's what you should learn by this time. See, in previous question also, they given HCF of two numbers is 21. LCM is 221 times the HCF, means, you know, this 221, this 21, 21 cancel. This 221 is the product of two numbers. That's the shortcut. When they give LCM is so and so times the HCF, okay, that anyhow these two numbers will cancel. That number, what are they mentioned, how many times, that is the product of these two. Here x and y, but here this is L and m. L and m is 204. Now what is the question they are asking? Difference between the two numbers is 60. Means x minus y is 60. From this L minus m I can find out, yeah, x minus y is 60, which is 12L minus 12m. We can divide with 12. L minus m is 5. Okay, now two numbers, product is 204, difference between them is 5. Difference between them is 5. Now they are asking x plus 5, which is 12 into L plus m. You know, L minus m, L into m. Okay, we should calculate L plus m. If you know, then 12 times that is your answer, my dear friends. So say this, okay, how to sort it out. Okay, two numbers with difference 5. 204. Okay, split this as a two numbers product, but there should be difference of 5. Difference of 5. Okay, so 204, generally square root of this is around 14. So it should be in the range of 13 and 17, like that. You just think about which is suitable. Okay, difference should be 5. Difference should be 5. Product of two numbers should satisfy 204. 204. See guys, yes. 13 into 17 is 221. No. 12 into 16. No, it will not satisfy 192, right? Now, near to that, two numbers product is 204. Difference. If you don't get idea, sir, we'll go with the normal method. I know L plus M is nothing but square root of L minus M whole square plus 4LM, sir. We can do this. Yeah, you can do that, my dear friend. We are not saying no for that. You can also do like that. But you just think about this product, my dear friends. You may get the clarity. Yes, sometimes you should save the time. How can you save the time? Is yes, you can think about how to write that 204 as product of two numbers. Yeah, they given 204 only here. Or else here, if you do like this, what will happen? L minus M whole square is nothing but 5 square, 25. 4 into L into M. L into M is 204 already. 4 times that will give 816. This is root 841, which is nothing but 29. L plus M is 29 you got. Okay, I can say 12 into 29, which is nothing but 348. My answer is completed. But this is not the method we are recommended in exam. So I'll just check it out. How many of you are done with that product, my dear friends? Yes. How you split it out? Yeah. Completed. You split out. This should be split as two numbers product. That idea you should get, my dear friends. Yes, sir. This is 12 into 17. Very good. 12 into 17. 5 gap, right? 5 gap, not 12 into 16. 12 into 17. Here, yes, 17 minus 12. That's what L plus M is 12 plus 17. We got 29. That idea you should get. Okay. How you go to that range nearby is I'm doing square root. I'm going nearby. Which range? Is it 20s or the numbers is in tens? Okay. As difference is 5, I'm just going close to square root of that. Okay. It should be in the range of 10s or 20s or 30s. At least I should know before doing the trial and error, right? So 12 into 17, my dear friends, very good. So yes, difference is 5, product is this. So guys, okay, we're done with only properties related and basic questions. Applications part we'll cover in the next session, my dear friends. Yeah, we're done with only properties, two properties related questions and ratios model of LCM and HCF. They asked the question ratio model, and we are yet to done this applications part. Okay, LCM and HCF applications that we'll cover in the next session, my dear friends. Okay, hope you learned something throughout this session. We'll go ahead with the next session with LCM and HCF applications, my dear friends. Thanks for attending. Okay, keep on. Make sure you people are active by the 7 p.m. Every day we have sessions. Utilize the free webinars, my dear friends. Okay, happy learning, dear.